In this section, we want to begin by reviewing some of the things that you've done previously with graphing. Here we have three equations on the board. First of all, I have y equal 1/2 x, y equal x squared minus 4, and then x squared plus y squared equal 25. Let's graph each one of these. So first of all, y equal 1/2 x, that's going to be a straight line. It's going to go through the origin because the y-intercept is 0, and it's going to have a slope of 1/2. But I can also substitute numbers in for x, get numbers out for y, and plot those points. So when x is 0, 1/2 times 0 is 0, so y is 0. So that goes through the origin. Now I could put in x equal 1, then y would be equal to 1/2. Let's put in x equal 2, because when x is 2, 1/2 times 2 is 1, and I get a little nicer point to work with. So I get that point. And if I put in x equal 4, 1/2 times 4 is 2, so I'll end up with this point right here. And you can see I'm getting a line that has a slope of 1/2, that is rise over run is 1/2, and it goes through the y-axis at the origin. Okay, I'll also get this point right here when x is -2. -2 times 1/2 is -1, so y is -1. Likewise, -4, -2. So I can draw a straight line between these points, and that will be the graph of y equal 1/2 x. Alright, let's look at y equal x squared minus 4. This graph is going to be the graph of a parabola. I can substitute in some values of x, get out values for y. When x is 0, I'll have 0 squared minus 4, which is -4, so y is equal to -1, 2, 3, 4 when x is equal to 0. Now if I substitute in x equal 1, 1 squared is 1, minus 4 is 3. Sorry, minus 4 is -3. Likewise, if I substitute -1 for x, -1 quantity squared is +1, minus 4 is also -3. And then I can substitute in x equal 2, 2 squared is 4, subtract 4 is 0, so I'm up here. Likewise, when I put -2 in for x, -2 squared is 4, subtract 4 is also 0. And let's try one more. When x is 3, I get 3 squared, which is 9, minus 4 is 5. So 3, 1, 2, 3, 4, 5. I'll get that point, and I'll also get that point when x is -3. So if I connect those points with a nice smooth curve, I end up with the graph of y equal x squared minus 4. Okay, for our last one, we have x squared plus y squared equal 25. I know because of the form of this equation that it's the equation of a circle. The center is at the origin and the radius is 5. So I'll just go out 1, 2, 3, 4, 5. Up here, 1, 2, 3, 4, 5. Likewise all the way around. And I'll get, I don't know if I can draw a nice circle here, but I'll try. I get the graph of y equal of x squared plus y squared equal 25, a circle with a center at the origin and a radius of 5. So you can see each of these equations right here has a graph that looks like this. We have a straight line, we have a parabola, and we have a circle. So these are the kind of things we're going to work with in trigonometry, and we just wanted to review a little bit how you go about finding these graphs. Let's look at a distance formula problem. Let's find the distance between the points 3, 7 and 6, 3. Well, the distance between those points by the distance formula is the square root of the difference of the x-coordinates, so let's say 6 subtract 3, quantity squared, plus the difference of the y-coordinates, let's say 3 subtract 7, squared. But notice that since I'm squaring these differences right here, it's not going to make any difference what order I do my subtraction in. So you just want to know what's the distance between 6 and 3 and what's the distance between 7 and 3. So if I work those out, I get the square root of, okay, 6 subtract 3 is 3, squared is 9. And then here I have 3 subtract 7, which is -4, quantity squared is 16. And I think you can see that that's going to be the square root of 9 plus 16 is 25. And let me take that over here. Square root of 25, positive square root of 25, 5. So just a little review of the distance formula. We take the difference of the x-coordinates, square that, difference of the y-coordinates, square that, add those two things together, take the square root, we get the distance between those 2 points. Here's another problem. We want to show that the point 1/2 square root 3 over 2 is on the unit circle, which has an equation of x squared plus y squared equal 1. Now we're going to be doing a lot of work in trigonometry with the unit circle, so the more familiar you become with it, the better off you'll be. A nice simple circle centers at the origin and the radius is 1, so it doesn't get any easier than that. But we want to know, is this the type of point that we're going to find on the unit circle? Well, let's find out. Does it satisfy the equation? So is 1/2 squared plus square root 3 over 2 squared equal to 1? I'll put a little question mark there, because if it is, that means that this point is on the unit circle. It satisfies the equation. Okay, well 1/2 squared is 1/4. Square root 3 squared is 3, and 2 squared is 4. So I have 1/2 plus 1/4. Is that equal to 1? Yep, sure is. So the answer is yes, this point is on the unit circle, the equation of the unit circle being x squared plus y squared equal 1. Let's go to the next board. Here's this nice diagram from the book that has all these important angles on it that we're going to be working with throughout the semester. 30 degrees, 45, 60, 120, 135, 150, so on and so forth around this circle. So the more we work with these angles here in the beginning, the better off we'll be later on. So let's see if we can use this diagram to find the complement of 45 degrees. Well, here's 45 degrees right here. Its complement is the angle we add to it to get 90 degrees, and you can see that 45 degrees sort of splits the first quadrant right there. So its complement is this angle right here, which also has a measure of 45 degrees. So the complement of 45 is also 45. Now, how about angles that are coterminal with 300 degrees? Well, here is 300 degrees right here. Okay, so coterminal with that, I could say, how about negative 60 degrees? That's one angle, one negative angle that's coterminal with 300. I can get here by either moving around this way to 300 or moving down this way, minus 60 degrees. Either way, I end up there. Now, how about one more where I actually wind around here once and then come up to the 300? So that will be 360 degrees. That's once around, plus 300 degrees. And so that's going to give me 660 degrees for going around the circle like that. Okay, let's move this down a little bit and look at angles that are coterminal with 30 degrees. Okay, thank you. Coterminal with 30 degrees. Okay, this may be a little harder to see right now because we zoomed out on it, but here's 30 degrees right here. Okay, where are all the angles that are coterminal with 30 degrees? Well, here's 30 degrees. I can go that way. I can also go backwards around this way. I can go once around the circle and get there. I can go twice around the circle and get there. Anytime I add or subtract a multiple of 360 degrees to that 30 degrees, I'm going to end up with an angle coterminal with it. So all angles that are coterminal with 30 degrees we can write this way. 30 degrees plus 360 degrees times k, where k is an integer. K is 0, plus or minus 1, plus or minus 2, plus or minus 3. Every time I put an integer value in for k, I get either once around this way or once around this way. Then I add 30 degrees to that, I'm going to end up coterminal with 30 degrees. So here's a nice simple way to write an infinite number of angles that are coterminal with 30 degrees. Okay, let's try one more problem. Okay, here I've written the angle 135 degrees in standard position. The initial side's along the positive x-axis, the terminal side is over here, and this is 135 degrees, so this is 45 degrees right here, so you can tell that this angle sort of splits this quadrant. Now let's see if we can do a couple of things with this. First of all, let's find a point on the terminal side of this angle. Well, because this angle splits the quadrant right here, we know that the coordinates have the same absolute value. That is, the point x equal -1, y equal 1 is on there. The point x equal -2, y equal 2. The point x equal -3, y equal 3. Anytime the absolute value of those coordinates are the same, when the x coordinate will be negative, the y coordinate positive, we'll get a point on the terminal side of this. I think in the back of the book we use the point x equal -3, y equal 1. Let's just try a different point. How about if I go up here and call this point the point x equal -1, y equal 1. So I go out here and up here, back 1 and up 1, I'll end up on the terminal side of 135 degrees. So for my point, I'm going to say -1, 1. Okay, how far is it from the origin out to that point? What's the distance from the origin out to that point? Well, I could draw a little right triangle right here. Sometimes we call that the reference triangle. In that triangle, the length of that side is 1. The coordinate of that point right there is -1. It's 1 unit back, but when I'm talking about just the length of a side in a triangle, the length of that side is 1. The length of this side is 1. It's a right triangle, so I can just use my Pythagorean theorem or distance formula, either one, and end up with this. That distance is the square root of 1 squared plus 1 squared, which is just going to be the square root of 2. So if the point -1, 1 is on the terminal side of this angle that's in standard position, then the distance from the origin out to that point has to be square root 2. So I'll write that in. Okay, and how about an angle that's coterminal with that angle? Well, let's see. I can get to 135 this way, or I can get to that same terminal side right there by going the other way. Well, what's that going to be? That's going to be 180 degrees plus another 45 degrees. 180 degrees plus another 45, 225 degrees. And since I'm going in this direction with it, it's minus 225 degrees. So coterminal minus 225 degrees. So these are all things that we're going to be doing a lot of times in this course when we get to the definition for the trig function. So you want to pay attention to problems like this. What is standard position for an angle? Can you find a point on the terminal side? If you do, can you find the distance from the origin out to that point? All those numbers are going to be very important, and then we'll do a lot of work with coterminal angles. So all of this is just kind of practice getting ready for what we're going to do when we find the trigonometric functions.